Hey guys, it's Layla. Today we'll speak about the reactions of alkanes and alkenes. First, I'll do the homework from my organic basics video. So you had to name some compounds. The first one is actually called 1,2,3 propane triol, but it is glycerol. Okay, it is always literally known as glycerol, and it's very important in the topic of lipids. The second one was propyl benzene. You had a benzene molecule with propyl attached. The third one was propanol. So you had an aldehyde group, which is null, and you had an alkene, so propanol. The fourth one was benzaldehyde. Now you could have thought of benzal or benzenol. You wouldn't be wrong, but it is known as benzaldehyde. Okay, and the last one was propionic anhydride. So you had two propionic acids combining to give you a propionic anhydride. Okay, starting with today's lesson, we'll start with alkanes. Alkanes, they mainly undergo substitution reactions. And if you remember, the general formula was CnH2n plus 2. All right, so alkanes mainly undergo two types of reactions. One is a halogenation, and another one is oxidation. But very rarely you'll come across this, the second one in the exam. So halogenation is the main one, and substitution, which means that it substitutes one of the atoms in the alkane. So you know our halogens, are fluorine, chlorine, bromine, and iodine. So let's say, for example, we have methane and we have chlorine. What do we get? We just substitute one hydrogen and we get chloromethane. And you know hydrochloric acid. Let me show you the mechanism. You just remove one of the hydrogens and substitute it with a halogen, and the hydrogen goes to the chlorine, giving us hydrogen chloride. Another example is chloromethane with a halogen again. You just add another chlorine, the mechanism is the same, and you get hydrogen chloride. All right, so chloromethane with chlorine, giving us dichloromethane and hydrogen chloride. In order to understand where you have to place the halogen, you need to know that tertiary carbons should be given more priority than secondary carbons, more priority than primary carbons. What I mean by this is, for example, here we have a tertiary carbon, right? A carbon attached to three other carbons. And if I have to halogenate this, my bromine will go to the hydrogen, will substitute the hydrogen on the tertiary carbon, not any other carbon. And what do I mean by secondary carbon? For example, here we have a secondary carbon and we have to halogenate it with bromine. Now I will substitute the bromine on the secondary carbon. It can either be there or it can be there, because both of them are secondary, but not at the end of the chain, because that is primary. Now moving on to the second type of reactions is the oxidation. As I said, it is rare. For example, let's just say potassium manganate, which is a very strong oxidizing agent. We are going to get an alkane alcohol. All right, so if I take ethane, I'm going to get ethanol. The mechanism, so one hydrogen attaches to the oxygen to give us a hydroxyl group, and the oxygen will attach to the carbon. All right, now we will move on to alkenes. Alkenes, the general formula was CnH2n, and they undergo mainly addition reactions. Because they have a double bond, that is the primary target for attack, and the double bond is broken and things are added to the compound. So there are 4 different reactions that we can see with alkanes. So one is hydrogenation, the second one is hydration, the third one is halogenation, and the fourth one is addition of halides. Halides are hydrogen halides, for example, hydrogen bromide, hydrogen iodide. Okay, starting with hydrogenation. It is just adding hydrogen to the alkene. So for example, let's take ethene plus hydrogen. It will give us the alkane. So it goes from alkene to alkane, ethane. So the mechanism is the hydrogen will just attack the double bond, break it, and 2 hydrogen atoms will get attached. So do you remember the general formula CnH2n of alkenes? And when you add 2 hydrogens, if it's 2n plus 2, it becomes an alkane. So that is the principle here. The second one was hydration. Hydration means adding a water molecule. So if I take an alkene and I add water, I'm going to get an alcohol. Okay, for example, again, let's take ethene plus water. We're going to get ethanol. The mechanism is the same. So the water molecule is going to attack the double bond and attach 1 hydrogen and 1 hydroxyl group to the carbons. The third one was halogenation. So it's the addition of fluorine, chlorine, bromine, or iodine. And again, the mechanism is absolutely the same. It is going to attack the double bond, and but instead of giving us only one, like in alkanes, it's going to give us dichloro or dibromo. Okay, so for example, here we have ethene plus chlorine. It is going to give us 1,2-dichloroethane. Moving on to the last one was addition of halides. If we add a halide to alkene, again the mechanism is the same. You will break the double bond and you will attach hydrogen and chlorine or bromine or whatever the halogen is, and in this reaction you're going to get only 1 chloro, not like halogenation. So that is the main difference. For example, with ethene and hydrogen chloride, we're going to get chloroethane. Before I end today's lesson, I want to tell you about Markovnikov's rule. Now, this is going to help you to place the halide in the correct position. So the main thing you need to know is the secondary carbocation or secondary carbocation. Carbon in the middle, not at the ends. Okay, that is our secondary carbon. And the rule says that when you have a halide, the negative ion, which is the halide, will attach to the secondary carbon, and the positive, which is the hydrogen, will attach to the ends. This is only if you have a double bond at the end of the chain. For example, here we have propene. If we add hydrogen chloride, on top we will have Markovnikov's rule, and at the bottom we have anti. So in Markovnikov's rule, the double bond will be broken, of course, with the halide, and the bromine, or sorry, in this case the chlorine, is going to attach to the secondary carbon. In the anti, the chlorine is going to attach to the primary and the hydrogen is going to attach to the secondary. What is the principle behind this is that when the hydrogen binds to the end of the chain, the carbon in the center gets a positive charge, and this charge will attract the negative halogen. But compounds generally follow the Markovnikov's rule. Alright, moving on to the homework for today. I will give you 3 questions on reactions. So the first one, I would like you to show me the reaction between butane and iodine. And please name the product. For question number 2, I will give you an incomplete reaction and you will have to complete it for me by filling in the red blanks and name the product as well. And for the last question, show the chlorination of propene and name the product. That is it for today. Take care. Bye.